15-year-old son told me, and I can't tell it here. So. But we're having drinks afterwards in the foyer, so if you come and see me then, I promise I'll tell you the joke then. So, I'm getting heckled already. Have you seen this? You just can't get the crowd these days. Welcome everyone, and good evening. Welcome to the UQ Energy Initiative Energy Express seminar. You can already see the title up there, so I won't read that out. Mine's a much shorter one. Mine just says, "The real work begins post-Paris." And I'm going to introduce you to our guest. Our guest is Professor Ottmar Edenhofer. Ottmar is the Deputy Director and Chief Economist at the Potsdam Institute for Climate Impact Research. He's also a Professor of the Economics of Climate Change at TU Berlin. He's a former co-chair of Working Group 3 of the IPCC, Director of the Mercator Research Institute, which is up there on the screen, advisor to the World Bank, advisor to many scientific committees, much published, and even, we understand, an advisor to the Pope. So on that, I'll just introduce Ottmar Edenhofer. Thank you.
So thank you very much. Can you hear me? No. No? Why not? So I switched on the whole thing. Is it better now? So then I do it here from the mic.
Is that okay?
Yeah, that's okay. Oh, okay, it's okay. So thank you very much for the kind introduction, and thank you very much for being here at the University of Queensland, a wonderful campus and a wonderful university. I very much appreciated the whole day to be here and to discuss interesting issues with important and interesting people. Now, basically, I have been asked to give a lecture on the Paris Agreement and what should be achieved and pursued in the next 2 years. Now, my lecture has basically two parts. In the first part, I will be very pessimistic, and after I have achieved the maximum of pessimism, I gradually increase my optimism, and I modestly conclude with some optimistic remarks. First of all, it is important from my point of view to take stock. So what is our current situation when we speak about climate policy? And here, my first message is the emissions are rising. And even if you compare the growth rate of emissions in the last decade, we have seen the highest growth rate since the 70s. So unfortunately, these are the IPCC numbers, and the IPCC numbers are ranging from the 70s to 2010. But even if you include the recent numbers, so this will not change the picture very much. So in the last decade, we have seen the highest growth rate, and probably will see a little bit a slowdown of the growth rate. But the most important question is, and this is something which is enormously important, what was the reason for that? And what can we expect in the future about emission reduction? And this is something which I would like to highlight here. At first glance, it is useful to decompose the growth of emissions in two components: population growth, GDP per capita, energy intensity, and carbon intensity. And let me start with the first two components, the population growth and the GDP per capita. What you can see here is that population growth in the last 3 decades becomes relatively less important compared to GDP per capita. And it's also quite interesting to see that the enormous contribution economic growth made to the increase of emissions, but this is only one side. This has also a positive message, because in the last decade, the world has seen not only an average growth rate, but also a remarkable decline in absolute poverty. So there are the other two components. The first one is energy intensity. Energy intensity measures how much primary energy is needed to produce the GDP. And it is absolutely remarkable to see the decline of energy intensity at a global scale. Energy intensity hasn't not only improved in Europe, in the United States, but all over the place. And we made significant progress in energy intensity, in particular in the last decade. However, this improvement, this technological improvement, has been overcompensated by far by economic growth and population growth. So the last component, this is the carbon intensity. Carbon intensity measures the carbon per unit primary energy. So from the 70s to the 2000s, carbon intensity has been declined, not significantly, but it has been declined, because at a worldwide scale, we have substituted coal-fired plants by gas-fired plants. And this was due to the fact of the relative prices of coal and gas. But interestingly enough, in the last decade, this whole process has been reverted. So let's analyze this a little bit more, because it is worthwhile to get a better understanding. First of all, it's also remarkable to analyze the contribution of the renewables. And again, these are global numbers. These are not just the numbers from Europe or from the United States. And it is remarkable that new PV and wind has contributed at a worldwide scale to the reduction of emissions. And also biomass and waste, and to a certain amount nuclear power. So I take into account in all this calculation the enormous technological progress made by PV, for example, and wind. But nevertheless, this technological progress has been overcompensated by the coal renaissance. Again, we started to replace gas-fired plants by coal-fired plants, and what was the reason? The reason was a very simple one. It is the power of the relative prices, because coal was much cheaper than gas. So, and this is something which is very important to understand, that we are in the middle of a coal renaissance. And I will say a little bit more in a few minutes. So what can we expect for the future? This is just an analysis of the last 2 decades, but the crucial question is, what can we expect for the future, for the next 10 years? Are we basically doomed or trapped in this coal renaissance, and what can we do about this? So this is the global stocktake. Now, let me say a few words about the aspirational goals formulated in the Paris Agreement. Now, first of all, the Paris Agreement argues that the increase of global mean temperature should be limited to 2 degrees, and even, if possible, well below 2 degrees, and the 1.5 degree target is an important aspirational goal, because without mentioning the 1.5 degree target, the Paris Agreement wouldn't be a diplomatic success. Why? The small island states want to have the 1.5 degree target within the agreement and ask, so to say, the global community to acknowledge the climate risk of the small island states. Now, the 2 degree target and even the 1.5 degree target has some kind of scientific underpinning. But what I would like to communicate very clearly, neither the 2 degree target nor the 1.5 degree target can be derived from a physical or a climate physics formula. It is nothing more and nothing else than the application of a precautionary principle. And therefore, the IPCC has highlighted a few risk categories, because in the end, the IPCC rejected an overall cost-benefit analysis where we tried to aggregate all the climate impacts into a single number and saying, these are the damages of the climate impacts. Because this has a lot of ethical and also a lot of scientific challenges, which I will not highlight here. And therefore, the IPCC said, what we want to do is, we want to inform the decision makers about different risk categories. And let me highlight a few of them. The first one, and all these names are not good at all, within the IPCC, we have no reputation to produce accessible graphs and also nice titles. So nevertheless, even with very complicated titles and inaccessible graphs, you can be very famous and even very influential. So the first one is the unique and threatened systems. These are basically the coral reefs. Then extreme weather events, the distributional implications of the climate impacts, the global aggregate impacts, and the large-scale singular events. So let me just highlight the large-scale singular events. So nobody knows exactly what is the probability for the large-scale singular events, but if they happened, and basically most of them are fat-tail distributed, so they have can have an enormous impact on the planetary machinery, like the change of the monsoon dynamics, the potential dieback of the Amazonian forest, the meltdown of the glaciers. So, and what most impact researchers are arguing is, so limiting the increase of the global mean temperature around 2 degrees compared to pre-industrial level, so would reduce the likelihood and the probability that these events will happen. So this is fundamentally a kind of a risk management approach. Climate policy, mitigation policy has the task to mitigate the dangerous impacts of climate change. And this is an inherently value-laden issue, because translating a climate impact into a damage is in itself something you need values, because a damage is something which is important for human beings, and then you have to explain decision makers and humans why and to what extent they are threatened by climate change. And by the way, because the 2-degree target is measured from the pre-industrial level, we have already increased the global mean temperature around 0.8 degree, so then we can afford another 1.2 degree. So, and even from a purely climate impact side, a 1.5 degree target might make the whole thing, from a climate impacts perspective, even safer. Now, I will not go into the details here. I would like to just to highlight one important impact category, which is not very well presented in the IPCC report. And this came out a few months ago by our colleague Marshall Burke. And this is something which refers and has a narrow focus on just on the economic impacts of climate change. And when I say economic impacts, this basically means on the growth rate of the GDP per capita. So basically, in this study, they assume that GDP is measuring all the relevant economic activities. We know GDP has only a very loose relationship to the human well-being, but nevertheless, it tries to give an aggregate number for the economic activities. But surprisingly enough, they found out from a macro and microeconometric perspective a quite stable relationship between the annual average temperature and the growth rate in GDP per capita. And what you can see here basically is there is a kind of an optimal temperature for economic activities. If it's too cold, it is very hard to carry out economic activities in the agriculture sector, in the manufacturing sector, and even if it's too hot, it's the same. So what they did is, and basically in most of the previous studies, before the Marshall-Burke studies, they've had a very strong focus on agriculture, on water, on food security, but it's not surprising, worldwide, the contribution of agriculture to GDP is very, very low. But if you try to measure the labor productivity, you have to include basically all relevant sectors, not just the agricultural sector. You have to include the manufacturing sector, you have to include the construction and the building sector. And it is obvious that in many countries which is too hot, this has a very strong negative impact, for example, in the building sector. And the impact on the GDP, therefore, is relatively high. What they did so far, they tried to measure the impact of unabated climate change, and you can see that Europe does not only has very low damages and can even benefit from climate change, North America, in a worst-case scenario, they will experience remarkable declines in GDP per capita. It is quite obvious that for Latin America, for the Middle East and North Africa, for Sub-Saharan Africa and South Asia, you have a strong decline in economic activity, a strong decline in the GDP per capita. And this is very remarkable because this figure shows that climate change has at least the impact to amplify the inequality across world regions. And we are here in Australia and in Europe, we are now debating very heavily and very intensely what we call the migration crisis. From this part of the world, what we call in Europe a migration crisis might be just a regular inflow of people from other countries. So in Europe, the sensitivities has been increased. But if you look at the European numbers here, and if compared with the Middle East and the North Africa, it is quite obvious and conceivable that climate change could have an impact on migration, a significant impact. And this is something which clearly shows that climate change, unabated climate change, many parts of the world might achieve the limits of adaptation. Because when I have shown such numbers 3 years ago, many people argued, oh, come on, migration is not a big problem, governments can adapt, governments have the capability to handle it. But currently, given the European capability to handle migration, so people become more and more pessimistic. What I am saying here is to say, based on these numbers, just to hope that in the future we can adapt to climate change is basically a very risky hedging strategy. Now let me come to the most important point of the fifth assessment report of the IPCC, which gives me an opportunity to evaluate the economic impacts of climate change. And the first thing is, whatever we want to achieve with respect to limiting the global mean temperature, it can always be translated into a cumulative carbon budget. And this is very important because there is almost a linear relationship between the cumulative carbon budget and the increase of global mean temperature. Now, this is a very worrying insight. Why? Because when nature plays out its card, in particular in the second half of this century, it might be the case that the climate damages are lower. All the climate damages can be much higher. But the most important thing is we can then do nothing to mitigate climate change. We have only then two options. We can either adapt to climate change, or we can think about solar radiation management, where we inject, for example, aerosols into the atmosphere, because then we could steer the radiation balance on Earth directly. I'm not saying this is a real-world option. What I'm saying is this is then the only option we have. Why? Because the cumulative amount of carbon dioxide emissions which has been released into the atmosphere determine in an irreversible way the increase of global mean temperature. Now, if we want to achieve the 2-degree target with a reasonable likelihood, and here we have a likelihood of 66%, so then this can be translated in the total carbon budget of 3,000 gigatons CO2. Since industrialization, we have already used 2,000 gigatons, so then we have remaining 1,000 gigatons. So this is the magical number coming from the fifth assessment report of IPCC. Now, this can be translated in an emission reduction profile between 70 and 40% by the mid of the century. So this range, 40 to 70%, depends very much on a portfolio of technologies which we called in the IPCC the carbon dioxide removal technologies. I will say a few words about this in a few minutes again, but what does it mean? It does mean that we need technologies in the future which allows us to absorb carbon from the atmosphere. We call this negative emissions. So negative emissions can be achieved by large-scale afforestation, the large-scale use of bioenergy in combination with carbon capture and storage. I can tell you these carbon dioxide removal technologies are highly controversial because we have an ongoing debate to what extent large-scale bioenergy can be used in a sustainable way. So think about 200 exajoule bioenergy per year. So this is something which has definitely an impact on food security and biodiversity. Some people are exploring new ways of negative emissions, for example, direct air capture, where we try to absorb CO2 with artificial trees. I'm not saying and arguing that these are necessarily purely science fiction technologies, but they are definitely not proved to be upscaled at a global scale. But nevertheless, we are not saying here these are mature technologies. What we are saying is, if we want to achieve these targets at reasonable costs and with realistic emission reduction profiles, we have to think now about this portfolio of technologies, which would allow us, in the best case, to have negative emissions. Now, what does this mean for the great transformation? Many people argue that a 2-degree target and a 1.5-degree target will impose a huge, large-scale global transformation process, and these people are right. So what this figure simply shows that you have basically a business-as-usual scenario of emissions without a climate policy, which basically says these are the emissions which will happen in the future without the climate policy. And then you have this line here, which is basically consistent with the 2-degree target, and the difference between what will happen and what should happen could be called the emission gap or the emission wedges. So, and the emission wedges clearly shows that you need a strong increase in end-use energy efficiency. We will use fossil fuels, but we can only use them with carbon capture and storage. We need a lot of renewables. We need also biomass and CCS. So you might be surprised, for example, why nuclear power plays, at first glance, such a little role in this scenario. And you might guess this has a lot to do because I'm coming from Germany and Germans do not like nuclear power. But this is not true. What this figure shows is it compares the relative contribution of the different technologies compared to a business-as-usual scenario. So in the business-as-usual scenario, in many of these scenarios, we have already a lot of nuclear power, and the additional contribution of nuclear power is relatively little compared to a situation for renewables, where renewables are have a tiny part in the business-as-usual scenario, and in the policies scenario, in the climate policies scenario, therefore, they have an increasing contribution here. Now, I would like to show you just this from a global perspective, and without going into the details, it might be interesting to look for a while on this graph here. And first of all, you can see the primary energy in the baseline scenario. In the baseline scenario, you fundamentally see, without climate policy, we will stick to a fossil fuel-based energy system. And I will show you in a minute that this is due to the fact that we are not running out of fossil fuels. We have abundant fossil fuels, and this is very well reflected in this baseline scenario. We will have a little bit nuclear power, a little bit solar at the end of the century, and you might debate with me about some of the details, but these are fundamentally the scenarios which are provided by many people in the IPCC. We have evaluated almost 1,300 scenarios, and they basically show the same picture. At least in the baseline scenario, we have a little bit of disagreement. What is the importance of coal? What is the importance of gas? But by and large, so in the baseline scenario, there wouldn't be a need to transform the energy system. So here you have done the primary energy, and in the primary energy you see that BECCS plays a role, nuclear plays a role, solar plays a role. And it might be also interesting to look at the electricity sector, at the power sector. And here you can see, in the case of a climate policy, basically by the mid of the century, we have to fully decarbonize our power sector, full stop. This is something which we can see also in all the scenarios, and I show this just for the US, the European Union and China, and basically all this energy system has to be transformed fundamentally. There are some differences between regions, but by and large, it's the same picture. And here you can see also compare the baseline just for the electricity sector. I will not go into the details because the main message remains the same. The decarbonization of the power sector is something which we have to do. Now, let me highlight this important figure here, because this figure brings it to a very simple point, and this is my favorite slide when I should explain the economics of climate change mitigation. I told you that we can release into the atmosphere 1,000 gigatons CO2 with a remarkable uncertainty bar. I come to that later. But the problem is, with climate policy, that we have 15,000 gigatons CO2 underground. Admittedly, we will not extract all the reserves and all the resources underground because we have increasing extraction costs. But even if we compare the amount of resources which are economically viable with the one which we can use in the case of a climate policy, it comes down to the following numbers. We have to leave 70% of coal and 1/3 of oil and gas underground if carbon capture and storage is available. And here it is important that we take into account the storage part of carbon capture, of CCS, because the storage part basically allows us to find an additional reservoir underground, which in the end enables us to use more fossil fuels which are underground. So that's basically the message. If carbon capture and storage is not available, either because of social acceptability or economic reasons, 90% of coal and 2/3 of oil and gas has to remain underground. And this implies nothing more, nothing else, that climate policy devalues the assets of the owners of coal, oil and gas. And given this simple fact, you might appreciate why the Paris Agreement was almost a diplomatic miracle. Because Saudi Arabia, Qatar, Russia, and China agreed to the Paris Agreement, which basically means that the world community as a whole agreed that the majority, at least of coal, has to remain underground. Now, from a purely conceptual point of view, we have three options, three important options. So the first one is, I could call the first one the engineering option, or put it a little bit more theologically, you could say, hoping for a miracle. I don't know if you believe in miracle. As a Catholic, I deeply believe in miracles, but I do not rely on them. But at least I could tell you how the miracle should look like. So let's assume that tomorrow morning we wake up and we realize that the levelized cost of electricity for wind, for example, is much, much lower than the levelized costs of coal. So this would be indeed a miracle, because nobody then would have an incentive to use or to extract coal. But the problem with this approach is the following. It could be the case that this is not a miracle which happened once in time, but it takes time. It takes the next 2 decades. So the costs for renewables might come down, and people will use less fossil fuels, but what would be then the implication? Renewables will make the fossil fuels even cheaper. And the renewables, the more successful they are, the more incentives they create to use the fossil fuels. So in that sense, then we are in a situation worldwide that even if we are successful from a purely engineering point of view, that we might increase the share of renewables in our electricity system, in the power system, but at the same time, we have a very high share of coal. And in the end, this will not lead to a reduction of emission. There is a second option. The second option is we compensate the users of coal, oil and gas for leaving their resources and reserves underground. So I leave it aside to what extent this might be a politically realistic option. The crucial problem is that even if we would be able to compensate the owners of coal, oil and gas for leaving their resources and reserves underground, this would imply that the incentive to invest in new exploration technologies, they will have the strong incentive to invest more in the future. Because if they invest more in the future and they will be successful, they will receive a higher compensation. And there are many examples, and it is not very well appreciated in the international community how large and how fast the technological progress was in the exploration industry in the last 2 decades. The only realistic option I see is the third option. And the third option is we need a carbon price. A carbon price which reflects the true scarcity of the limiting disposal space of the atmosphere. Because for the 21st century, not the fossil fuels are scarce. We are not running out of the fossil fuels. It's the disposal space of the atmosphere which is the most important scarcity factor in the 21st century. And this is in deep contrast what the Club of Rome, for example, has told us for almost 2 decades, that we have to do and we have to implement climate policy because it's a hedging strategy for the running out of the fossil fuels. But this is not a good argument at all, because we are not running out of fossil fuels, and given the limiting disposal space, we have too much fossil fuels. Okay. This is an interesting proposal thinking about carbon pricing, and it's admittedly by no means a new idea. So this idea has been advocated for decades by economists, but they advocated it, and the public and the decision makers simply ignored this. And the crucial question is, so how can we achieve something on the carbon pricing front, so to say? But before I go into this detail, so let me highlight a little bit what Paris really means. Now, first of all, in Paris, I mentioned this, we have 2 focal points. One is the 2-degree and the 1.5-degree target. And let's translate this a little bit more in detail in the budgets. For a 1.5-degree target, and this is the uncertainty range, we have, in the worst case, no more budget is available because we have exhausted all our budget. In the best case, there might be 200 gigatons available from now on. And by the way, in the last 5 years, we have already released 200 gigatons CO2 into the atmosphere. The 1.5-degree target simply means and implies that each ton of CO2 which is emitted today has to be compensated at a later stage. So for each ton of CO2 in a 1.5-degree target, we need negative emissions in the future. So the situation looks a little bit more interesting or a little bit more promising for the 2-degree target, because this is the range of the carbon budget. In the best case, we have the 1,000 gigatons available. I mentioned this. In the worst case scenario, it's almost around 400 gigatons. Now, the Paris Agreement has another part, another important institutional innovation, because the Paris Agreement does not rely on enforceable commitments, on a binding target or on binding national targets. The Paris Agreement was only a success because diplomats had a brilliant idea. They asked the governments what they would like to contribute on a voluntary basis to the global public good. And they contributed, and in plain language, they agreed in Paris that by 2030, they will exhaust the whole global carbon budget, which is consistent with the 2-degree target. And say it a little bit more scientifically, so then this means in the best case So in 2030, 400 gigatons are available, but in the worst case scenario, we have already accumulated negative emissions, which basically means more than 200 gigatons of CO2 after 2030 has to be compensated. So that's basically the problem with the Paris Agreement. High aspirational goals, but a level of voluntary contributions which are in the best case almost consistent with the 2-degree target, but in the worst case, which imposes a burden to the future generations because they have to compensate the emissions which we have produced by 2030. But it's even worse because if we take into account the emissions from existing and planned coal-fired plants, we end up with more than 500 gigatons CO2. It's 550 gigatons CO2 with the planned coal-fired plants and with the existing ones. And now you have the answer here. Are we in the middle of a coal renaissance? Yes, we are still in the middle of a coal renaissance. Why? Because we are planning in an unprecedented way coal-fired plants around the globe. And if we implement these coal-fired plants, and we might agree after 2030, we should reduce the emissions annually by -6%, which is then consistent, roughly consistent with the 2-degree target. So my guess is this is not agreeable at all, because the countries who have implemented this modern and most of the time highly efficient coal-fired plants have absolutely no intention to devalue their assets and their investments. So in that sense, we have now a window of opportunity, a door of opportunity for the next decade. But if all these coal-fired plants are implemented around the globe, the door for the 2-degree target and the 1.5-degree target is closing, from my point of view, in an irreversible way. And this is the reason why I believe it's not the time to continue an unproductive debate about the long-term aspirational goals. The Paris Agreement provided relatively reasonable focal points. Let's say a reasonable focal point well below 2 degrees. But the problem is, how can we find a short-term entry point into a climate policy? And let's talk a little bit about that. And from my point of view, it is absolutely crucial and essential that we now talk about carbon pricing, because in these countries here, they are responsible for 90% of the investments in coal. It's China, India, Turkey, Vietnam, Indonesia, South Africa, Korea, Japan, Bangladesh, and Taiwan. And by the way, so in Germany, we are not planning new plants, but in Germany we built up since 2002 11 coal-fired plants, which is very interesting. And we have the same dynamic in Poland. So the only reason why they are not showed up in the list is that their capacities are so small that from a global perspective, it's not a big deal. But for this country, it's a big deal. And the renaissance of coal does not stop in China. It's an ongoing process in these countries. Now let me highlight it now. I hope I have convinced you that we are in the middle of a very complicated process. I have achieved now the maximum of pessimism, and now I start to become gradually optimistic. Because I become gradually optimistic, because I feel a solution for a short-term entry point is at least in reach. Now, what can we do? Now, until 2018, so the international community has agreed to come up with a global stocktake, and they agreed also they would like to increase the level of ambition. Now, how can this be organized? From my point of view, the most important thing is that we translate the voluntary contributions, they are called the intended national determined contributions, in the UNFCCC language, that the voluntary contributions should be translated at least in implicit carbon prices. Why? Because the carbon prices measures the contribution, the effort an individual country undertakes. And what we know from cooperation research, this is very important. If you want to continue cooperation among countries, you have to do two things. You have to build trust, and you can only build trust when there is transparency about the contributions of the people, of the individuals or the nation states. Currently, we have no transparency. Many countries have provided INDCs, voluntary contributions, where they say, we want to reduce our emissions by X% compared to an undefined baseline. So therefore, what we have to do is translate these voluntary contributions in an implicit carbon price. What will this exercise tell us? This exercise will tell us there's a huge range of carbon pricing across the globe. And this is not a surprise, because many countries have different willingness to pay and different preferences for a climate policy. This is what we should expect. And this is also what we expect from cooperation research. Now, the next step is then, how can we convince the poor countries, the countries who have a relatively low preference for climate policy, to increase their carbon prices? Why should we convince them? We should convince them because countries have a strong preference for the global public good of a stable climate or avoiding dangerous climate change. Other countries have a lower willingness to pay, and therefore what we should do is, the donor countries, for example, they should provide transfers to the poorer countries in a conditional way. They should say, if you increase your level of ambition, if you increase your efforts, we provide you a conditional transfer. And this is one of the nice things in the Paris Agreement, that there is a known chapter on climate finance, and within this chapter of climate finance, there is already an institution which is called the Green Climate Fund. However, it is not decided yet how to use the Green Climate Fund, and my proposal would be design the Green Climate Fund in a way which provides conditional transfers to the recipient countries, and in addition to that, do not limit the amount of the funds, but rely on the self-interest of the donors. The donors have a self-interest to pay transfers to the countries who have a lower carbon price, because then they get a higher level of the public good. And in addition to that, they can reduce emissions in these countries where the marginal abatement costs are much lower than in their own countries. So this would be, from my point of view, an important institutional innovation to develop the Paris Agreement along these lines. Now, an additional component here is that we have to think carefully outside the UNFCCC process about carbon pricing. And the first and the most important insight here is that at a global scale, carbon prices are highly distorted. So you might think that at an international scale we have carbon prices which are around zero. But this is not true. Because if we take into account all the subsidies in our calculation, and we include, for example, the health costs which are caused by the fossil fuels, so we can conclude that 1 ton CO2 at average worldwide is subsidized by $150. We have significant carbon prices at the global scale, but unfortunately these carbon prices are negative because we subsidize the ton CO2. So this is the first step. We should get rid of the fossil fuel subsidies. In addition to that, we should increase the carbon prices very, very soon. So there's an additional argument here. An additional argument here is why, or the question is, why should a finance minister interested in carbon pricing, either via carbon taxes or carbon trading scheme, even he or she is not interested primarily in climate change. And I tell you, the finance ministers I have met all over the globe are not terribly interested in climate change. However, in the current G20 debate and in the current preparation of the G20, there is one overarching theme, one important agenda item on the international agenda, and this is called the infrastructure gap, in particular in the developing countries. So people, finance ministers around the globe are interested in infrastructure investments, for example, in roads, in water, in clean electricity and transportation and telecommunication. So we carried out a calculation and come up with a number that 12 trillion US dollar per annum are needed in the next 2 decades to finance this infrastructure gap. Now think a little bit about this infrastructure gap and how can we finance it. In some parts of the world we might impose user charges for roads, for example. We can also finance public transport schemes via land rent taxation. China is very successful in this regard. We could also use private finance coming from the multilateral development banks. They are becoming increasingly important financing the infrastructure gap. We could use the carbon prices, the reduction of subsidies, and partially also increase the public debt. So there's a huge range, a large range of financial tools which could be implemented in the next 10 years. And carbon prices and the reduction of the fossil fuel subsidies are important, and also, by the way, land rent taxation could be extremely important to finance clean public infrastructure systems. Now, we did a calculation, a rough calculation, and calculated the costs around the globe for clean water, clean electricity, and asked the question, what is the potential, just the potential of carbon pricing to finance this infrastructure gap? And we come up with the conclusion that except for roads, where in Africa and in Latin America the costs still partially exceed the revenues, so for all the other items, we can basically provide a universal access to clean water, clean electricity, sanitation, telecommunication. And this is, from my point of view, a remarkable result. Because in many cases, carbon pricing is preferable to taxing capital, to taxing labor, increasing public debt. And this is basically why I modestly and moderately optimistic that finance ministers learn over time that this internationally coordinated carbon prices provide for them an additional source of revenues, because these carbon prices are not channeled to a supranational organization or institution like the UN. These are carbon prices where the revenues remain within the country. Admittedly, there's a transfer scheme, but the transfer scheme is quite modest and can be facilitated by an institution like the Green Climate Fund. Now, let me, in my last point, so this is something where I tried to convince you that now the G20 debate and the G20 summit, the presidency of China and Germany, could provide such a short-term entry point. And I have no intention to bother you here with, with European issues, but when now Germany in particular and Europe wants to undertake an effort to convince other countries that carbon pricing is the right way to do, so then Europe should reform its own European emissions trading scheme, because this scheme, from my point of view, is malfunctioning. And let me explain this a little bit, because it is, from my point of view, quite a revealing fact why we failed. Now, first of all, what you can say positive about the European emissions trading scheme is it delivers the cap. And if you speak to officials in the EU, in Brussels, they will always respond to any kind of criticism about the EU emissions trading scheme. It delivered the cap, and they are right, indeed, it delivered the cap. However, the question is, what is the reason for this price decline? And again, according to the narrative, which is favored by many officials in the EU, the narrative runs as follows. They say it delivers the cap, and because of the remarkable technological progress in the renewable sector, but also in the other carbon-free technologies, we learned over the last few years that climate policy is incredibly cheap, because we have this kind of decline in the price. And according to them, the price decline is fundamentally driven by technological change. So by the way, it's interesting that after Paris, so we had a further price decline in the EU. I will come to that later. If this would be the case, that technology change and the market fundamentals would drive the price decline, so we would be happy. Now we could say, we are in a wonderful world. Economists made a lot of calculations in 2005, and they came up with incredible high carbon prices. Again, they failed because they are making all the time bad predictions. Technological change trumps, and then we are now in a wonderful situation where climate policy is much cheaper than we thought. So we did an econometric study, and we came up with the conclusion that only 10% of the price decline in the EU emissions trading scheme can be assigned to the market fundamentals. 90% has other reasons. They are not coming from technological progress, from fuel switch and so on. So what was the reason? And again, we did an event analysis, a very extensive event analysis, and it turns out, basically, that the price decline was driven by destabilized expectations of the traders and the investors. Whenever the Commission says something on backloading, the investors become very, very suspicious, price their declining trust, and this leads to a further price decline. So to cut a very long story short, you can say the EU ETS has been transformed from a marketplace for climate change, for mitigation technologies, into a betting shop for policy decisions. From a social science perspective, this is wonderful, because the EU emissions trading scheme provides us with enormous amounts of information how traders and investors perceive political decisions. And this price decline tells a very interesting story. And the story is that even after 2020, the traders do not expect a remarkable scarcity in the EU market. Because fundamentally, they do not trust, they no longer trust the politicians. And, this is also quite important, they anticipate, to a certain extent, a renationalization of the climate and energy policy in Europe. For example, we have now a debate in Germany why Germany should phase out coal. But what does this mean for the European emissions trading scheme? If Germans want to phase out coal, we create an additional supply on the market. This leads to a further price decline, and this sends additional incentives for building up coal-fired plants in Poland. So the hotspot in Germany, in eastern Germany, it's the hotspot for coal. It's very close to the Polish border. Do we really believe in Germany that we can phase out on one part of the border, phase out coal, where the same emissions trading scheme sends a signal to the Polish investors to invest in coal? I think this is not a winning game at all.